We started discussing about the two data structure as part of Pandas. One is series, and we started exploring how to use series a little bit. So this is how you can define a series. In order to use a series, you need to explicitly import series from the package Pandas. Usually we use the command import. It's a reserved word. Followed by that, you need to specify your package name, numpy as np. So this is an alias. You can give whatever name you want it, but this is the most popular and widely used alias. So hence strictly follow this name and import pandas as PD. Okay, I have imported these two packages, but if I want to use the series, you need to use explicitly something from pandas. So from this package, pandas, this is a reserved word, keyword. From pandas import series. The series, the series, yes is capital. So you need to use import and import OS. OS, I imported it for some other purpose, but it is not mandatory. If you want to work with the pandas or numpy, you have to import OS. Okay, but I imported for some other purpose. Okay, so the next one is we explored how to ingest a CSV file into a data frame. See in pandas, look here what I did in the pandas package. We have something called read underscore CSV function or method. In the first argument, you need to specify the file name with the correct folder name, and then the separator, whether it's a comma separator or semicolon separator, you need to specify it explicitly. The SCP is a keyword, equal sign. After the right side of the equal sign, you need to specify. In some projects, some clients they'll be using semicolon. Some clients I have seen they are using pipe symbol. Some clients they use double pipe symbol to separate one column to another column. They use double pipe or single pipe in the CSV file. So in our case, the columns are separated by comma. And encoding. So what type of file? Type of something like encoding. So you don't have to worry about this at this moment. So here what I did, I just clicked on it. See, PD is not defined. I directly clicked here. So what is the problem here? I did not execute this code snippet. I need to execute this one sequentially, because before you load the data from a CSV file or any file into the data frame, make sure that you imported the data frame. Only when the only when the relevant packages got imported, you should be able to load the data into data frame. If I execute this one, look here, now it will work. So now with this type function, we can understand this is not a simple variable. df is no more a simple variable. It is a data frame. So pandas.core.frame.data frame. This is the data frame. So with this, we are able to make sure that this variable become a data frame. This variable holding all these values in the memory. So when I select here the df is the data frame name now. So here, if you want to see the total number of rows and columns, you can use shape command followed by df. It gives you the total number of rows and number of columns. 25,000 records are there. In real-time scenario, you might be having 25 million records or 35 million records. So in that kind of situation, don't simply type df. It will try to load entire 25 million records. In the case of development environment, all you need to do is you need to check randomly the given data. So it is not that always you need to check top 5 records. If you want to explore the data to get a quick insight, right? So high level idea about the data. So what you need to do, you need to use a head function. In the head, you can specify the number of records. In this case, I mentioned 5. If you want to see the top 5, top 50 records, you can see it, especially if the volume of the data is very high, you can do it that way. So this is how you can find out the top 5 records. And if you want to see the last 5 records, you have something called tail. So I click on this cell. So watch carefully. So this is your line number 11. Currently I'm in line number 11. And if I scroll down, I can see the top 5 records. Each record's index values start with 0, 1, 2, 3. Each record has its own index. These index values were assigned behind the scene by the Pandas package. And now I found these records are little bit clumsy. So just alongside this data set, if I data rows, if I point the cursor here and if I double click on it, it'll be hidden. Okay. Whenever you want to see the data, you just click on it once, you can see the data. It'll get collapsed when you click on it, double time. Okay, and if I click the insert cell, I want to see the last 5 records, df dot tail of 5 records, last 5 records. If I want to see it, I can see it here. Last 5 records. Look here. In total, we have 25,000 and odd, right? 25,004 records. Of the 25,004, you need to ignore this one. Okay, the column header, including that one, 25,004. Excluding that, we have 25,003 records. See, the last record is 25,003, the index value. And this one and last 5 records it shows. From the bottom, last 5 records we can find it here. So you can use df tail. So they'll ask you the questions. How do you find the top 5 records? How do you find out bottom 5 records in a data frame? So you can use head function, you can use tail function. And once you display the top 5 records, and you can explore the data to gain any insights, okay, at a high level, whether the quality of the data is good or not, something like that. So you can just scroll across the right side. You can find all these things here. Okay, see here dot dot. Since we have so many columns, what it does is up to state and then it put dot dot. So the certain columns will not be visible. Rest of the columns it shows. Fine. So these are the things. And if you want to see only the columns from the data frame, okay, you can see it here. df.columns and df.dtypes is very much helpful to display the column name along with the data type. So in Power BI, so we could see the column name in the report canvas. On the right side of the report canvas, you find the column names. And if you want to see the data type and data, you need to go to the data view. Similarly, right? So here it is a little bit different. If you want to see the column name with the data type, you can see it here with df types. So followed by the data frame name, you need to put dot and then you need to type d types. D type stands for data types. And the next one is category. So this is the column name which is available in my data frame. Okay, if I wanted to see the data from a specific column, you need to specify the data frame name followed by the dot. Followed by the dot, you need to specify the column name. So this is how you can select the value from a specific column. Alternatively, what you can do is you can use square bracket, df square bracket. Here you can use category. Here also one second, you need to use quote here. Yes. So df is a data frame, square bracket category. So what is the difference between these two? There is not much difference. Sometimes what will happen is if you have a column with this name. So what happens is in this case, see these two words are related to single column, but it has a space, in between these two words, right? So here we have space. So in that kind of situation, if you specify df dot country space state, the compiler will read up to df dot country. Followed by that, if any space is there, it will simply think, okay, the column name got ended here. It will consider only country, and then it will display this value instead of displaying this value. So what you need to do is, in that kind of situation, this is very much helpful. So for example, country state. If you specify inside the code, the column name, and especially like this kind of column, right, wherein you have space. right? So the compiler will logically think, okay, so these two words belong to a single column name, which is available in this data frame. Because you might be in real time, you might be using n number of data frames. Maybe more than one data frame can also have the same column name. Hence, you need to say the data frame name and the column name. Like in a street, your family head, or for example, a similar family head name may have the same name of children's. See, family one, listen, James, and this son name is John, James John. Other family can also same thing, right? To distinguish that he is a James John, and John is a son of James, and James is son of Samuel, something like that, right? So to distinguish that, you need to specify family head and the children name. The same way, data frame name and the column name. Just maybe a stupid analogy, but remember this. So either you can use simply like this. If you don't have space in the column name, you can directly use it this way. If you have a space in the column name for a single column, within a single column, if you have a space, you can use a data frame, something like that. So here, unique df dot category unique. Unique is a function. So this is the column name followed by the column name. I want to explore further. See, data set is given by management. As a data analyst or data scientist, it is our custom, or it is our responsibility to explore what values are there in each column. Instead of knowing blindly what values are the column, is not only sufficient to get some high level insight. You can use functions like this. Unique function will give you the distinct values in a column like this. In category, these are the distinct. So under these three categories only, this customer is selling the products. You are able to get a high level insight like this. And followed by this, we have a function called value counts. Value counts is very much helpful to help us to understand each unique value or distinct value, how many number of records are there. Fine. So the next one is we have something called dot all loc and dot illoc locators or available. Dot illoc is kind of a deprecated one. So for example, okay, let me do this. So the illoc and dot illoc. For example, if you want to view only the more than one column. So here category, I want to view only the data that are there in category. Fine. If I want to display only two columns, see here, if I click on it here, it will get expanded. So top 5 records, I can see it here. In this top 5 records, I can see all the 26 columns. And for top 5 records, I can see it. I don't want to see all the 26 records. See, with the help of 5 or 10, you can specify 8 or 10, something like that. So top 8 records will get shown. So with the help of head function, we can subset the data. Only portion of the data, if you want to select it. This is one way of doing it. Okay. And okay, we are able to subset the data by row. Is there any way if I can subset the data by columns? Yes, that is where the dot locate function is very much helpful. So there is something called locator. Yeah, we will go step by step. So we will go step by step. We'll see that one also. I'm going to show you that one now. Okay. So here, for example, if you want to see something like df dot locate. So locator can help you to find out, for example, if I specify more than one column, segment, comma, city, and if I give like this, or in the index, okay, here what I do is, I see 0:3, something like that. So I wanted to view the top 3 records using locator. So the locator dot loc and illoc. So these two functions are helpful to locate the records based on the label. Dot locate function is helpful to retrieve the data based on the label, whereas .ilocate is helpful to locate the or to select the records based on the index values. As I told you, each record will get assigned with the index value behind the scene. Okay. So now what I did here, I just simply selected the values from a two columns. I don't want to view all the 26 records. All I need is I want to see only the specific records. Here, I just write the syntax df.locate. Here, start colon end. So all of you n minus 1. So that is what is happening. Df dot, sorry, in the case of end, in the case of df dot ilocate, start colon end minus 1. This is like a list. In list, this is how, if you want to select the range of values, you can use if you specify colon, you can use colon. If you want to select the range of records or range of values, we use record the colon in list and other thing, right? Even in the tuples. Same way you can use colon to select the specific range of records in a data frame. So we have two functions, or one is locate and ilocate. As the name suggests, ilocate, in this case, integer based location, okay, index based locate. So the n minus 1, start colon. Whenever you use ilocate, it will use start colon minus 1. Whereas in the case of dot locate, it literally goes by the label based search. Label. See, if you go to a shop, let's say you want to buy some products, 3 products. So on top of the product, they put some label, right? So if you literally, it goes by the label. So wherever the 0 is there, 1, 2, 3, literally go and select all the records whose index value start from 0, 3, 0, 1, 2, 3. And I will use the ilocate and see what will happen now. So if I use ilocate, so 0 colon 3, start is 0 index and n minus 1, it applies the n minus 1. So here, yeah, here what will happen is, here also you need to specify the index value. Okay, so okay, okay. For example, here, let me do one thing here, df dot columns. 5, 6, 7, 8, right? So here 5, 6, 7, 8. Okay, here I should have mentioned 7 here, 7, 8. Even for the columns, when you use ilocate, integer based located, so here also you need to specify the column. See here, in this case, the first one is the starting and end. You need to specify the record index value, start index value, end, comma, which column. I don't want to see all the columns. For example, if I simply say df locate 0 colon 3, what will happen here is, it will display top 3 records, but all the 26 columns. I don't want to see all the 26 columns. It is kind of a mess for me. All I am interested in, I want to see only the values from these 3 columns, but top 3 records for these 3 columns only I want to see it. So we want to subset not only the rows, even the columns. So with this, we are able to subset only the columns, specific columns. But 0 colon 3, I want to see it. But same thing, instead of using locate, I use ilocate. 0 colon 3. But when you use integer based locate, instead of specifying the column name, you need to specify the index value for the column name. So 7, 8, what is 7? That's why I used df dot columns to find out the index value for the segment. So here 5 is there, right? So 1, 2, 3, 4, 5, 6, 7, 8. 8 is the index value start, even for the column names, the index value start with 0. 0 to 7. The 7th index value points to segment, 8th index value points to city. 7 comma 8. Okay, but in general, we use label based locate only label based search. This is called label based. It literally goes by 0, 1 to 3. Whereas iLocate, it acts like your list. The list, how do you do slicing? If you give 0, 3, starting from the index value 0 to till the end, n minus 1. So the 3 minus 1 is 2. If you want to display similar to this output, you need to specify 4. 0, 1 to 3, 0, 1 to 3. Look here. Are you able to understand the difference between these two? So it is literally go by the index. I stands for index. Okay. Go by the index range. So the index range start minus n, start colon n minus 1. So this is the rule. It is applied for iLocate. But here literally it goes by, if you give 0, it will start from 0. And if you give 3, it will go literally by 3. It is not going to do n minus 1. That's it. Okay. And the next one is, for example, the same thing in the list, how we did. So here I'm going to simply say colon 3. If I say something like this, even this one also same here. So what I do is I just, these two produce the same thing. You don't have to specify the starting point. Here I'm going to remove 0. If I don't specify anything before colon, start from the first record. If I don't specify anything after colon, till the end of the records, all the records. Okay, but here I don't want to see everything. I want to see the top 3. So both of them are same. By default, it is something like colon here. I'll just show you that one also. If I simply specify colon here, but here what will happen is it will display starting from the 0th index to till the end. So 25,000. Look here, 25,003. It selects that much. Okay. So don't use this kind of thing. Okay. You need to specify starting or end value. Or if you want to select only the specific rows, also it is possible. You can specify the specific rows, like for example 0 colon 0 comma 3 or something like that. Okay, for example here, so to answer to Gilbert's question, how do I select specific records in between? So 2 comma 3, you need to specify the index value. You need to know the index value. The second, the row which has index value 2 and the row which has index value 3, only you need to select it. It is possible by doing this way. Or you can specify the range of values also. Here, instead of giving 2 comma 3, no, I don't want to see everything. I want to see 10 colon, index value starting from 10 to let's say 18, 17. If you want to see that, you can give this way. The range of values very much helpful. Here you don't have to give the square bracket in the case of range. In the case of range, you don't have to give square bracket. You need to remember this. But if I wanted to select the specific rows, you need to specify the square bracket, because the locate here, for example, I want to see the index value a 7, 8, 10, comma segment, comma city. Look here, 7, 8, 10. You need, but here you need to use square bracket because you are not using colon here. See, in the case of colon, the compiler can logically understand starting from the index value 10 to 18. You select the values. In this case, what will happen is you need to explicitly specify the square bracket. Why? Because here we are not using range 7, 8, 10. Likewise, you can use comma, comma, comma. So in that case, how the compiler will get to know whether the 7, 8, 10 is the the index value or not, right? So you will specify n number of index values here. So in order for the compiler to understand, you need to square bracket. See, these three values are related to the index, row index, and these are related to column name. Okay, but ideally when you use something like this, it makes sense. The locate level, in the case of ilocate, you need to specify the index value for the column name. Look here, even for it, this is for row, the range is 0:4, and but here the index value for your column name, 7th index points to segment, 8th index points to the city column. Okay, so here when you use ilocate, see, usually you just think about it. If you specify 7:8, later point in time, if you add any new column in between these two columns, what will happen? It will cause some confusion. Better you follow the label based search, df.locate, like this, right? So this is really helpful from the business point of a later point in time. If you want to verify the logic that you have used it in your script, this is very much helpful. So hope you understood the difference between the label based search and the locate function is basically helpful to slice the data based on the specific range of rows or specific rows or specific columns. You can do it with the help of df.locate. Okay. And if I want to do some kind of filtering, how do I do this one? I don't want to see here. I see here in this case, what happens is I need to specify the range of rows, 0:3, 0:100, or if I want to specify the column index, so column name I have to specify it, fine. But in real time scenario, we don't really use it. This is for exploring purpose, fine. So top 3 records, or randomly if you want to see the records, specific records, you can use this one. But in general, what we do is we use the Boolean filtering. You take anything, even in the case of Power BI or any software provides any RDBMS SQL queries, we use some filtering criteria. Based on some filtering criteria, I want to select the records. Usually, we do it that way only. For example, here in the segment, we have consumer. I want to view only the segment wherein so I want to view the consumer segment data. Okay, we want to use some condition based thing. So in that case, what I do is simply I can use something like df dot segment is equivalent to consumer. Look here. So inside the square bracket, I need to tell first of all which data frame I'm going to work. So my data frame is df. In this data frame, which column you want to use it? Segment column. In the segment column, based on which value you want to filter it, consumer, right? But here it displays all the columns. So here I want you to select only the specific records here, 0:3, something like that. And here it shows something like it's an error here. So unalignable Boolean series provided as indexer. Okay, what is this error? It tells us I can filter it directly using the I don't have to use dot locate, right? I don't have to use dot locate. I can directly use something like this, right? Look here. df dot segment equal to consumer. But when I use df.locate, I can do something like this. But here, when I use df.segment, it is not doing it. Will this work? It will not work, even in this case. Right? So the condition fails. Here, what you need to do is true or false. It gives me something like this. Okay, 0, 1, 2, 3. So Boolean filtering is happening. So how do I? Now the question is, let me see how many of you can give me the correct answer here. So how do I? So now if I select the row range starting from 0, 3, and where segment is equal to consumer, it is filtering it, but it is giving me true or false. So how do I get the values displayed only for the rows 0, 3? Okay, for the consumer, how do I do that? How do I do that? So why don't you type it in the chat window? How do I filter the rows by condition? But I want to select the rows. I want to filter the rows based on some condition, but I want to display only for the specific records. How do I do that? So if I want to use more than one condition in my logic, that is also possible. Okay, we have various options are available. We will go one after another. Okay, and okay, this is how you can do filtering for a specific rows. But here it is a little bit tricky. I will come back to that little later. Okay, about this. Okay, so the next one is, next what I am going to do is I'm going to start with the join conditions, and then I will come back here. Okay, and then I will come back here. So what are the types of joins that we can do it in Pandas? Okay, like in SQL query, we use the equi join, inner join, outer join, all the things we do it. The same way we can do it in this one also. What is your plus? I did not get. Sumiti, what do you say in between? Okay. Okay, here join, right? So import numpy as np. So this is another, look here, this is another file. I opened it. And here I already created data frame. Look here. Here I have used something called data frame function. What do you mean by function? A function is followed by open parenthesis and closed parenthesis. When I click the cursor here, so when I click it here, this one will get highlighted, the open parenthesis. The corresponding closed parenthesis got highlighted here with green color. So it starts from here and ends here. So inside this function, we need to specify the values or arguments. This is another way of creating the data frame. So here, how we create a data frame. I just use the read CSV. The read CSV function is available as part of your pandas, pd.readcsv, using which I read this file and loaded the data into a variable called df. Since I've used pandas read CSV function to load the data into this variable become a data frame. This is one way of creating the data frame. If you have a file externally available, you can create data frame this way. This is another way of creating a data frame. Look here, you have a function called data frame. So here, inside your Jupyter notebook, you can type the data, your own data, you can type it here. So in this case, what I did, I used a dictionary. So in the dictionary, I specified the name colon. This is the key, and this key is holding 3 values. This is another way of creating the dictionary. Okay. And the second argument of my dictionary is color. This is the key, name, color, year. All these 3 column names are related to keys, and each key can have more than one value also in the dictionary. Okay, and comma index, I mentioned the index value also 0, 1, 2 here. And when I execute, what will happen is my data frame name is df1 cos. Okay, and here in the df1 cos, the column names are name, color, year got created. In the name, I can see in Lexus, Ferrari, and Mercedes values. The index value also got assigned 0, 1, 2. The advantage this one is you can specify your own index values also. Instead of 0, 1, 2, you can specify 1, 2, 3 or 3, 2, 1. You can specify some text value also. Okay, I don't want to complicate that much level. Simply I create a data frame using data frame function, because in this case the data is not available in my operating system, in my Windows operating system as a CSV file. So I create my own data inside this one. This is kind of static data. Okay, this is the data and data frame. Okay, so this df1 cars data frame has 3 columns and 3 rows in it, and the row values, the row index value, we have assigned it 0, 1, 2. So that is what we can see here. Similarly, I'm going to create another data frame, df2 cars pd.data frame. Here I created the index values here. Here the index value I intentionally gave 0, 1, 3. Instead of giving 0, 1, 2, I mentioned 0, 1, 3. This is to demonstrate how to perform joins in Pandas. Okay. So before we jump into understanding the different types of joins, let us see how we can do the append. I want to combine the data frame, combine the data frames row wise. How do I combine the data? So for example, I have some concat df is equal to pd.concat. What is pd.concat? So there is a function called concat that is available in Pandas. pd.concat. Here I want to combine these two data sets, df1 and df2 cars. These two data frame, I want to combine it. Since I want to combine more than one data frame, I need to use square bracket list, the square bracket list, because list of data frame names I'm going to say. If I want to have this, in this case, I have two data frame, df1 cos, df2 cos. In real time, you might be having 8 data frames. If you want to combine the 8 data frames into single data frame, so you need, if you use the list of data frames, right? So the square bracket. So why square bracket has to be used? You can specify as many data frames as possible within this list. But according to the concat function, this is only one argument. Okay, the list of values. So here, next one is axis equal to 0. This is very much important. The axis equal to 0, and you have another option like 1. So axis equal to 0, row wise, you can concatenate the data. df2 cars, it's not cars, it's cars. No error, it got concatenated. Now let us take a look at what value, after combining these two data frame, what values are there in this one. We can see it here. Look here, 0, 1, 2. This is the one, right? This one and this one got combined. 0, 1, 2 has these records, and 0, 1, 3 belongs to df2. These two table, we can say table or data frame, right? These two tables data got appended one after another. df just the below this df1 cars data frame, we have inserted the df2 cars values. We can say that way, because in real time scenario, let's say your customer is giving you 10 weeks sales data. Each week data is available in different data frame. If you want to combine all the 10 weeks into single file, you'll be using concat function. But again, the same rule applies whatever we discussed in Power BI. All the columns, all the files columns should be in the same order. For example, in this file, the column name, color, year is there, the same order, other files also the column should be there. If it is not there, you need to reorder it correctly, and then only you need to do concat. Supposing in this data frame, the column name starts with color and then name and then year. So what will happen is blindly it will get appended, but in the color column, name value will get loaded, and the name column, the color value will get appended, will get loaded. The whatever the file that you use it first, right? The column order, name, color, year, the same order, this file should also be there. So you need to check the using df2 cars dot columns and see if the column names are in line with all the other data files column name order. Okay, name, color, year is there in this order only, it is there, then it is good. Then you can do the concatenation. And if I want to do some kind of, see here I've used axis equal to, so here row wise, I mentioned data frames, combine the data frames row wise. Is it possible for me to combine the data frames column wise? Yes, that is also possible. I just copy paste it in the interest of time. I don't want to type it here, axis equal to 1. If I give, what will happen is, if I click run, what will happen is, I don't see any error here. Concat df, if I do it and press enter, look here, side by side it got inserted. So what is common between these two, which index values are common between these two data frames? See, 0, 1, 2 belongs to one data frame, and this belongs to one data frame, and this belongs to another data frame. If you wanted to cut this one and put it alongside of this one, right? So for example, you want to cut this one and put it here. This is column wise concatenation. But in this case, what will happen is the 0 and 0, the 0th index, the index value for this row is 0, the index value this row. So this value get concatenated side by side. But here 1 is there. So this BMW white will get printed here. But here we don't have 2. We don't have any index value with 2 here. Hence, what will happen is it will put blank here, and then it will put 3 here. So because in this case 3 is there, and row number 3, and here there is no corresponding row number 3. In that case, you will get something like this. 1 second, let me just see row number 3 NaN. It puts NaN because in this data set, first data frame, we don't have values for the index value 3, but whereas in the second data frame, we have the row index 3, we have the values for the row index 3. Okay, and similarly here, in this data frame, we don't have values for the index value, row index value 2. Hence, it puts NaN here. Here it puts NaN, not a number. Okay. So got it. This is what column wise. In the case of column wise concatenation, side by side, it does this, and whereas the row wise, simply it appends this data frame values just beneath this records. So row wise, you can append the data, and column wise also you can do appending. But you need to give axis equal to 1. Axis equal to 1 tells do the column wise concatenation or append the data. Row wise, axis equal to 0. Axis equal to 0. You remember that 0 is row wise, 1 is column wise. This way, if you remember it, it will be pretty simple. Okay. And next, we will take a look at the typical join, the merge. We have something called merge command. Okay, so this is the concat, and next one is, look here, I have used another data frame. Before we go in there, I just demonstrate with this data frame itself how we can do the merge. And yeah, so I have something called df underscore m stands for merge. And we have like concat, we have merge function is available as part of and the df2 parse left index equal to true and right index equal to true. And also I'm going to do something like this. I just remove this one. By default, it is false. It is not doing anything here. Okay. So here what I did, the first argument, yeah, in the case of merge function, the first argument, your data frame, and second, which data frames you want to merge it. I want to join these two data frame. Left index equal to right index true. So which means based on the index, you join these two data frame. So in the first data frame, the index value 0, 1 is there. The 0, 1, 0, 1 is common for these two data frame. That's what we have seen it. Look here, for DF1 cars, 0, 1 is there. And in DF2 cars, 0, 1 index values are there, right? But whereas the 2 and 3 are not common between these two data frames. So based on the index, you do the join these two data frame. So 0 and 1, the index values are common for these two data set. We did this one. But here, if you see, after merging it, you can see name X, color X. So the same column name got repeated. But in this case, the column, each column got suffixed with something like, under X, underscore X. This to make sure that these three columns belong to this data frame. And these three columns, if you see, these three column names ended with underscore Y. So with this, we can find out these three columns belong to this one. For comparison sake, you can use it. So here, Lexus red 2012 and red 2013, Ferrari, something like, you can compare year wise, something like that. Okay, so in that kind of situation, it is very much helpful. Got it. So the next one is, if I don't specify anything, left index equal to true, right index equal to true. So how will it join these two data frame? It cannot join these two data frame because you know very well in SQL query, if you want to join the two data frame, you need to have a common column. If you don't have the common column between the two data set, you cannot do the join. So here we mentioned, hey, here, so the common column, we don't have it. Instead, you can use the row index value. So row index value is 0, 1. And the same 0, 1 was available in the second data frame. Based on the common row index value, you join these two data frame. But whereas here we did not specify the common column between these two data frame. This is common in RDBMS. If you want to join more than one data frame, you need to specify the common column between these two tables or two data frame. So in this case, there is an option called left underscore on equal to true, and right underscore on is equivalent to, left on is not true. Sorry, you need to specify the column name here. The name is name, right? Here, and right on is equal to name. So these two data frame has same columns, but based on the column name in these two data frame, you need to join it. If I do it, it gives me in both the data frame, the common name or Lexus, okay, Lexus and Mercedes. Okay, so based on the name, it merged it. If you see here, where is the, yeah, this is the first data frame and this is second data frame. See, since here I have used the column name. So name and this one belong to, these three data belong to DF1 cars, these two belong to, these three records belong to DF2 cars. And the common column, use the common column as name to join these two data frame. So in this case, Lexus and Lexus got combined, and we have Mercedes and Mercedes, but Ferrari and BMW, these two values are completely different. It is not common between these two. The Lexus and Mercedes, these two values are common between these two data frame, right? Since you are using name column as a common column to merge these two data set, what happens? Lexus and Mercedes, since these two values are common between these two data frame, it got merged that way. So left on, right on. The left side data frame, which column should I use it? The right side data frame, which column should I use it as a common column? So these two are common column for these two data frame, and use these two column as a common column and join it and give me the result, right? So that is what we are getting it here. Got it? Very simple one. So the left on and right on is very much helpful, using which you can do the join. So, and the question now is, can I do left outer join, right outer join? This is kind of an inner join. So for that, what I do is I use another data set, data frame. This data frame has, these values. Okay, here, what I am going to do is I'm going to use the same merge function, merge underscore frame, something like that. PD dot merge and df underscore subject, comma df underscore students. How you have a parameter called how equal to left. If you want to perform left outer join in the merge function, you can use how option, and you need to tell left on and right on. Left on section ID, comma right on is equivalent to class ID. You need to specify the column name with the proper case. If it is uppercase, you need to use uppercase merge frame. Left outer join. So you know what is left outer join. So you have the data set. I just repeat the logic behind the left outer join. For example, you have the data set, and see, left outer join is something like this. The common value between these two data set, and then all the value from the left side. I'll just put it like this, okay? So don't think, this is, okay, let me do one thing. I'll just round it off correctly. Yes, this is A and this is B. Let's say in A, you have 1, 2, and 3. And here you have 1, 2, 4. With this diagram, you should be able to understand. Left outer join is the common, what is the common value between these two data set? 1, 2. And then what is not common between these two on the left side? 3. So 1, 2, 3. Matching values between two data set and non-matching value from your left side table. So 1, 2, 3. The 4 will not come here. This is your left outer join. This is what we discussed as part of Power BI, and especially those did not attend my Power BI session. So this is the thing, okay? This is what left outer join. So look here, what is happening here is you have a data frame called df subject. You have another data frame called df students. So I want to do left outer join. Okay, in this case, I have used an option called how equal to left on in this table df subject data frame. Which column should I use it to do the left outer join? Section ID. In the right side, see, if you want to join two data frame, you need to use a common column, right? The common column need not to be same name. Here section ID is there. Here also, ideally, this is nothing but section ID. But for naming convention, real time, they use different name. Okay. So in this case, you need to talk to the customer and find out which columns can I use it to combine these two data set. Tell me the common column names for these two data set. So they will tell you, oh, section ID and class ID, both of them are same only, but here instead of specifying section ID, we mention class ID. But if you see the data, you should be able to understand. Sometimes with the data itself, we can. So ID1, ID2, ID3, 4 here, ID4, ID1, and in the students, and the students name, and here the subjects and semester, and index value, here we specified explicitly 0, 1, 2, 3, 4, 5, 6, 7. So when we do the left outer join, so inner join. So look here, this is your inner join. Okay, I just remove this one here. So this is left outer join, this is inner join. So you want to say left on, right on, how equal to inner. So initially here, when I used merge left on, right on, here I did not specify the inner, how equal to inner, I did not mention it. If I remove it, what happens? The same thing, right? That is what is happening here. If I use how equal to inner, same thing. So by default, it is inner join. With this, you are able to conclude. If you specify the common column name between the two data frame using left on and right on, it does the inner join by default. You don't have to specify explicitly how equal to inner. If you specify it explicitly, it is good because it is from the readability point of view, it is very good. Okay. So inner join, this is a left outer join. If you want to perform left, you simply specify left. And if you want to perform a right outer join, you can specify right. And if you want to perform outer join, full outer join. So what is full outer join? A union B, all the values from both the circle. So here I just specify outer. Full outer join 0, 1, 2, 3. Look here 0, 1, 2, 3, 4 index values. There's 0, 1, 2, 3 and 4 index values. But here the section ID and class ID, right? So I'm using the section ID and class ID based on which, not based on the index value. Okay, section ID. So what is the union? ID1, ID2, ID3, ID4. ID4, ID1. So look here, ID1 is here, ID1 is here, and ID6, ID2. Where is outer here? Outer gives me ID1, ID2, ID3, ID4, and NaN. So it gives me, look here, class ID, ID1, ID2, ID3, and ID4, ID6 also it gives us, right? So A union B, all the values, ID1, ID2, ID3, ID4, ID6, maximum, right? But duplicates, it will not have the duplicate values. So can you understand? So let me just, for those of you completely new and to outer join. So this is my A and B. So A union B, all the values, but no duplicate. For example, here you have 1, 2, 3. Here again you have 1, 2, 4, 5 is there. When you use A union B, what will happen is A union B will give all the values 1, 2, sorry, 2, and sorry, 1 second, 1, 2, 3, 4, 5. That's it. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. It will not repeat these values again. So that is what is happened. So ID1, ID2, ID3, ID4. So what is common here? The ID1 is common, hence it is not repeating it. ID4 is common, hence it is not duplicating it. Compared to these section ID and class ID, ID6 is different here. Only this one. So hence ID1, ID2, ID3, ID4, and then it gives us ID6 also. Look here. So if you see here, the outer join. This is what my outer join. You can see the ID6. But for this student David, there are no corresponding subjects are available in the subject one. So I will share this copy to you all. You can start practice it. But this is the idea: A union B, excluding it does the A union B, but it excludes the duplicate values. So outer join, inner join, outer join, left outer join, right outer join. Simply you need to copy paste this one. Instead of left, you type right. That's it. That is what your right outer join. So apart from this, we have merge function. Apart from merge, we have something else called join function. You can use join function also. For example, join df is equivalent to, so in my case, df subject. So which data frame? First, I want to use the subject and then join function. So data frame name dot join the second data frame. So df underscore students, comma, L suffix. You need to use L suffix or R suffix. but this is optional, but this is the best practice. Or suffix. So here, join these two data frame, subject and students. You join these two data frame. But here I did not specify any common column between these two data frame. So what is happening here? 0, 1, 2, 3. In the case of students, df subject, let me just print it here. Okay, and df underscore students 4, 5, 6, 7 is there, and df underscore subject 0, 1, 2, 3, and the index was 0, 1, 2, 3, 4, 5, 6, 7. But here I have used section ID, right? So it is not doing the, if I blindly use join, right? So I need to see the common rule of thumb is, if you want to join any data frame. So in this case, this data frame, if you want to join these two data frame, I need to use a common column between this one. So what happened? It simply put ID1, ID2, ID3, 4, and it joins this one, but it is not a proper join. So in this case, you need to specify the common column between these two data frames. So only then we can see it is joining the data set correctly. So in order to do that, so what you need to do, we have something called set index function is available. Set underscore index. Using set index, we can tell which column should be used between these two tables or to join these two tables, right? Which two columns are common between these two tables. Join and df students dot set underscore index. Here I'm going to specify class ID. This is the right way of doing it. So they use the common column between these two data set as section ID in this data set. In this data frame, use class ID as the common column. Sorry, this column. So these two columns common between these two data set. So using set index, we are able to define the common column between these two data frame, df subject and the df students. For these two data frame, the common column, we defined it using set index function, using which we are able to get the value correctly here. And similarly, what we do is we can use, by default, it is an inner join. You might be asking this one, how do I do the outer join or left outer join? Here we have something else called how. Here also how is available in the join thing. Set index. Here L suffix or suffix is not mandatory. It's not required. So here I'm going to say how equal to inner class ID, inner join. So the common value between these two data set, ID1, ID2, ID3, and section ID1 second. If you want to do the outer join, gives me A union B. And okay, so what is the difference between ID1, ID2, ID4? ID1, ID2, ID4, but what is the difference between, see if I don't specify inner, what is happening here? Can someone tell me? If I don't specify, okay, let me remove this one or suffix and all. Here I mentioned the common column between these two data set. See here, this is a section ID, here class ID, but I'm getting ID1, ID2, ID3, 4. But whereas here I have explicitly specified perform inner join. So what is the common value between these two data frame? ID1 is available here also. These two are common, and ID2 is also available here, and ID3, ID4 is available here, but whereas it is not available here, right? So ID1, ID2, ID4 is also available here. ID4 is also available here. So ID1, ID2, ID1, ID2, ID4 is available, but whereas the ID3 and ID6 is not available here, right? Class ID, ID1, ID2, ID3, ID4. So here I have used the students. In the students, there is no matching values. ID1, ID2, ID3, ID4, ID1, ID2, ID1, ID2, ID3, ID4. So this is the one it is displaying it. And ID4 is available. ID6, only ID6 is different. All the values are available. ID1, ID2, ID4, ID1, ID2, ID4s are available. ID6 is not available here. ID1, ID2, ID3, ID4. ID6 is not available. Hence, it is there is no matching. ID6 is available, but ID4 is also not available, right? ID4 is available. ID1, ID2, ID4, but ID3 it is displaying the ID3. So what is happening here is the 0, 1, 2, 3, and 4, 5, 6, 7. But the index values are completely different. And here. So even in this case, it is not doing correct job, right? So you need to specify explicitly how equal to inner. Whereas in the case of merge function, when you specify left on, right on, if you don't specify how equal to inner, still by default it does the inner join. But whereas in the case of join function, you need to specify explicitly how equal to inner. Otherwise, it will not do the proper join. So how equal to inner and how equal to outer, how equal to left, how equal to right, you can specify it. So the join function, you can use it. In the case of join function, you need to specify this way. Now the question is, what is the difference between join function and merge function? Both of them are doing the same thing. But the difference is here 0, 1, 2, 3, right? So here you need to specify how explicitly, how equal to inner, outer, right, left. You need to specify it explicitly. Otherwise, it will not do the proper join. So pandas join. Okay, I just say, okay, join. This is the join function, which we can use it. Okay. Next, what we are left with, we have something called okay, we will take a look at a little bit on the data visualization part also. Okay, and we will work extensively on the data analytics part probably later. Okay, and we have df.query function is also available. Okay, using which also you can query the data frame. And okay, so what I'm going to do is I just simply do some kind of data. How do we do visual? How to work with the visuals in Jupyter Notebook in Python. So we have a package called Seaborn and Matplotlib. So for that, even for the Matplotlib and Seaborn, I guess NumPy is a basis for that. Import pandas as PD and import matplotlib.pyplot as PLT. These are the alias. PLT is the look here. In this case, it is very much helpful. Instead of typing the package name every time, because the package name is very big one here. instead of typing the big one, you just type the alias. That is more than sufficient. That is where the alias are very much helpful. And next one is I'm going to import something called warnings. And yeah, I will show you later. In today's session itself, I'll show you what is warnings. You can see star here, which means once you, let's say once you typed your script here, and when you hit the run, and if you see star, that means it is trying to import. It is still in progress. Okay, you need to wait. So now the star got disappeared. That means all these packages got imported successfully. And now I'm going to use something called plot. PLT. What is PLT? The alias for matplotlib. Okay, so that's what plot. You might be wondering what is .pyplot. So this is one of the library or sub library that is available as part of this package. Okay, plt.plot, and here I'm going to say 3, 4, 6. This is x-axis, and y-axis values I say 8, 10, something like 14. If I press enter, what happens? So I could see some kind of plot here, right? So 3, 4, and 6, the x-axis, and the y-axis, 3 and 8, and the 4 and 10, 4 and 10. Look here, 4 and 10. So if you want to create a simple plot, we can give like this. Or if you want to use a scatter plot. What is scatter plot? When can we use scatter plot? If you want to find out the relationship between two quantitative variable. So 3, 4, 6, the same thing, 8, 10, 14. So these two, listen to, this is one list, this is another list. And if I give like this, what happens? Scatter plot. So scatter plot helps us to identify the relationship between two variables. Anyhow, we will take a deep dive anyhow, I will take another example. And with that, you should be able to understand. So for example, here, 3, 4, 6, 8, 10, 14 I have mentioned. So what instead of hard coding the value here, specifying the value directly here, I'm going to use some variable name. I say x equal to 3, 4, 6. That is my list, and y is equivalent to 8, 10, 4, 10. This is my another list. Instead of specifying the value directly, this is not the right way of doing it. You're not supposed to specify the value directly here. Instead, you can use the variable plt.s, y. And here I can give some meaningful name for each axis. For example, plt.label, x label, x axis, I want to give some meaningful name. And here I say age, and plt dot y label. Here I specify the income. Plt dot title income by age. So x-axis I want to give some name, and y-axis I want to give some name, and title I need to give it for this one. When I execute, look here, the title, PLT title got specified income by age, and y-axis I've given some meaningful name as income, and x-axis I have given the something like this. Okay. Next one is the univariate analysis. We'll see how we can do univariate. As the name suggests, we are going to analyze an individual variable. In this case, for example, I have something called income. Income is something like 5, 15, 20, 18, something. These are all in terms of thousands. You just think that way. And 8, 5. And bin, I need to specify the bin here. So the bin is something like 5 comma 10 comma 20 comma 30. See, the bin I discussed as part of the shape measures. And then plt dot, in the plt package matplotlib, there is a function called histogram. Income comma bin, if you specify it, you can plot the histogram something like this. Yeah, 5 10 20 30, that is the bin, right? So 5 10 15 20 25, something like that, right? So that is the bin. So the in the width of each thing, right? So this is the histogram. You can plot the histogram something like this. Next, what we will do is we will do some kind of data analytics using a data set. Let's say you are given a data set. I'm going to say mkd is equivalent to pd dot read underscore csv. I have retail marketing 29 June. I don't know if this file is there or not, because I changed my hard disk 2 or 3 times in the past. Let me see if it is mkd dot head function. Yes, good, it is available. So I'm going to use this data set to demonstrate how we can use the visuals like histogram or scatter plot, all those visuals, how we can use it to gain insight from this data. So here I can see that the top 5 records with the help of the head by default, even if you don't specify anything here, 5 or 3 or 2, if you don't specify anything in the head function, by default it will display top 5 records. And these are the columns that are available: customer, age, gender, own home, married, all these values are available. But if you look at these columns closely, amount spent and salary, these two are quantitative variable. Rest of them are and previous spent, right? So these three, oddly few columns are quantitative in nature, whereas rest of them are kind of categorical variable. Here, the own home. Can you all hear me? I'm getting some message like internet is not stable. Can you all hear me? Hello, hello. Yes, okay, thanks. So here, the gender column, if you see 0, 1, 0 is female, 1 is male. Similarly, it's a kind of a categorical variable. Own home is another column. 0 is, this customer 1 is not owning any house, which means he's living in a rental house. 2 is 1, which means is 1 is true, 0 is false. Okay, and married. So where this customer ID 1, he is not married and he is married. And what is close? This customer is close to my retail shop, and this is what is salary. In the children, here, though he is unmarried, he has a children, one children. This is something odd. Okay, and one children. But the previous customer, yes, this customer has already purchased in my shop. Previously spent this much in my shop. And catalogs. We sent 12 catalogs to this customer. It's kind of a brochure to promote the business or to attract the customers to visit our shop. We keep on sending the catalogs to the customer. So how many catalogs we send to each customer, that data we have it here. And the previously amount, how much they spent, and after sending the catalog, how much they spent now, amount spent. That is the data we have it here. So the age, gender, own home, married, and the salary and children, these are called demographic data. Demographic data about the customer. Now let us view only the columns, mkt columns. It is always a good practice to check the column and the data type of each. Though you can see the column with the data, better you can check the salary is a float and previous spent, amount spent, and rest of them are integer variables. Though it is integer variable, it is all kind of a categorical variable only. So we have amount spent. Let us see how this amount spent variable got the distribution pattern of this amount spent. We can take a look at it. So for that, we will use a histogram. The histogram function is available as part of our matplotlib itself. And my data frame is MKT. I want to view the histogram for the amount spent column. And I say the bins equal to 10. So create 10 different buckets. So with this, what you can infer, this is my univariate analysis. As part of univariate analysis, what I did, I just plotted an histogram for this column amount spent. So I can, with this, I can see that the data is right skewed. The amount spent is right skewed. So a majority of the customers have spent anywhere between, this is not exactly zero, probably this, $10 to almost $500. Majority of the customers they spend between $10 to $500. That's what we can infer it from this one. And next one is we will do something like bivariate analysis. So likewise, if you have more than one quantitative variable, you can use histogram function to check what distribution that column has in it. Okay, so this is right skewed, and next one is bivariate. So what you can do is you can extend this analysis by plotting the salary also. Bivariate analysis. Here we have some categorical with quantitative variable. So I just make it markdown, language table markdown title. And what I'm going to do this time, I'm going to use SNS. What is SNS? Seaborn, the alias for Seaborn. So the Seaborn is kind of an advanced version of Matplotlib. Okay, I'll show you, how it differs from Matplotlib. Okay, so with Seaborn, since there are some flip side of using Matplotlib, or there are some limitations with Matplotlib, they developed something called Seaborn. With Seaborn works well with Pandas data frame. It overcomes the flip side or the disadvantage of a matplotlib. So here the first argument own home x-axis, and second one what I'm going to do is I'm going to use the amount spent. Look here, the own home I used the square bracket because for these two are single column, but in between space is there, hence square bracket code. Ideally, since I use square bracket to specify the column name, for the sake of consistency, here also I'm using square bracket. When I click on this, let's see what happens here. Look here. So it gives me the box plot. So this is box plot. Using box plot, you can do bivariate analysis for the categorical variable with quantitative variable. If you want to do an analysis between categorical and quantity, scatter plot, when will you use scatter plot? If you want to compare or find out the correlation between two quantitative variable, we use scatter plot. The simple example is, as the price decreases, the sale also increases. When you reduce the price of the product, obviously sale will also increase. So price and sales, these two are quantitative variable. If you wanted to find out the correlation between these two variables, then quantitative variable, correlation between two quantitative. I'll just type it here so that you remember it. to find out. Okay, and if you want to perform analysis, right? If you want to perform analysis between the categorical and quantitative variable, so the own is a categorical variable, right? And amount spent. So if you want to find out, if you want to perform bivariate analysis with this kind of, see, in this case, both the variables are quantitative variable, price and sales. But here, the own is not the quantitative variable; it is a categorical variable. It has 0 and 1 only in it. The own home column has 0 and 1 only in it. 0 means they do not have house. 1 means they have house. Okay. So finding out the relationship between quantitative and so you can say the qualitative. So the quantitative, so this is quantitative and qualitative variable or categorical variable. You can use box plot. Here we can see that quickly those own house, their amount spent is the median amount spent. The middle one is the median. This line is the median. This line is the median. The median amount spent by the people, those who own the house is more compared to those do not own the house. And we can see these dot above this. See, this is the minimum value and this is the maximum value. This line we already discussed about scatter plot, right? And anything above this one is called your outlier. So we can see few outliers are there here. Even in this case, we have some outliers. So using box plot, we can find out the outlier. So what is the formula for finding out the outlier? Can someone type it in the chat window? Which formula that you use it to find out the outlier? And I'm going to use SNS scatter plot. You can use Googling. You can do Googling also. Formula to find out the scatter plot. Are these two variables are quantitative? Yes, numerical variable. In that kind of situation, you can use scatter plot. So we can see that as the salary increases, the amount spent also increases, right? So we can see up to this. So this guy 80,000. When the salary increases to 80,000, obviously when you get more salary, you will spend more. You want to buy more. You want to enjoy your life, right? So you will spend more. So there is a positive correlation exists between these two variables. With the help of scatter plot, we can understand these two variables are correlated and that there are some outliers here. So this value is too far from the rest of the values. Here also some kind of outlier. Okay, this is a little far away from this one. But if you draw a line here, somewhere here, so almost all the values are somewhat scattered closer to the line, but still some values are scattered a little far away from here. But it is, if you draw a line, it's kind of a scatter plot. Okay, the line is closer to somewhat here. So the next one is MKD. Here I just say amount spent. It is pretty easy to remember the functions also in Pandas. If I want to find out the average amount spent by the customer, mean function, you can use mean function. Okay, and next one is I just take this one. Instead of amount spent, I want to analyze the salary. Those people who own the house, their salary, median salary is more than those do not own the house. So with this, if you correlate that one with this one, since those people who own the house, the salary is high, their amount spent in my shop is also more. That is what the insight we are able to gain it. Are you able to understand? This is how you need to gain the insight. Your manager or someone, they will not give. They simply give the data. You need to plot it. With this, you need to understand. We need to tell the story to the management. So those who own the house, their median salary is more than those people do not own the house. and hence their median amount spent in our shop is also more. Hence targeting those people who own the house literally makes sense. If you send more catalogs to those people earn more or those people who own house, it makes sense. Instead of blindly sending the brochures to all customers, let's say your customer base is 1 million. If you send the brochure to 1 million customer and each brochure costs hypothetically, let's say $1. So $1 million customer, if you have to send the brochure for each customer, so 1 million into $1, $1 million you have to spend. But again, there is no assurance on all the 1 million customer after seeing your brochure, they will come and buy it. Instead of blindly sending the brochure to 1 million customer, I wanted to be straight smart. I want to find out of the 1 million customers, which customers are potential customers who spend already more in my shop. Those kind of customers, if I send the brochure, or especially those earn more, obviously they can come and buy it after seeing my brochure. Look here I'm getting the warnings, right? This looks clumsy. So what I do is, in that case, I'm going to use something called warnings package, import warnings, and warnings dot filter warnings ignore. So if you hit the run and if you come back here and if you execute it one more time, see, still it is there, right? No, the warning has gone. Look here, the warning has gone. Now it looks pretty decent. If you share it with your manager, you will find it more useful. Instead of sharing it with warnings, if you share it like this, it will be more useful for them. Next, what I do is, I told you the Seaborn package is a little advanced than the matplot library here. So what I'm going to do, I put the same thing here. There is something called hue option. Hue is equivalent to MKD gender. So I'm going to put one more dimension, 3-dimension now. In this visual, so far we have seen 2-dimensional only. So here I'm going to use box plot. So star, I can see that means it is still processing this command. We'll have to wait for some time. Sorry, here I need to use some categorical variable. Otherwise, it will see one categorical variable, one numerical variable, and then the hue I mentioned about this one. Look here, this gives me additional insight. So here within each category, 0 is one category, 1 is another category. 0 means they do not own the house. 1 is they own the house. And those do not own the house, within that itself, we can see the gender wise. So far, we have understood those people who own the house, they spend more. So within this, gender wise, if I see 1, so 1 is male. Those who own the house, and especially males spend is more. In that case, I'm going to target only the male gender. I'm going to send the brochure only to the male customers, those who own the house or those income is high, because this is the pattern we can see it. You understood how this analysis is helpful? See, guys, you just think that way. So you have 1 million customer. Your customer base is 1 million. Your customer base is 1 million. And the brochure, for example, each customer, if you have to send the catalog, each catalog cost $1. If you have to send the catalog to 1 million customer, what will happen? 1 million into $1, it will cost you $1 million. This is your advertisement expenses. Do you think it is wise to spend $1 million to make your customer to come and purchase from you? It is not wise. So what we do is, as a marketing manager, you explore the data. These are all the historical past data. Based on the past behavior of the customer, what you're doing, you're trying to explore the data using box plot, scatter plot. When you use this box plot, what you understood initially, when you started your analytic journey, you understood those people own the house, they are the ones spending more. And when you plotted salary, you were able to understand very clearly, and those people own the house, their income is more than those people do not own the house. And you decided, okay, those people own the house, they are the one are more likely to spend. But when you did, when you narrow down your analysis to gender within this, you are able to find out, for example, the those people own the house, right? So owners, the owner's population is, we have 1 million customers. They say 0.3 million customers are there, or let's say 0.2 million customers, they own the house. And again, if you spend $1 to send the catalog to zero point 0.2 million, right? 0.2 million dollar you need to spend. So when you did this analysis, you don't blindly send the catalog to zero point 0.2 million owners. Of these owners, male owners, right? So the male owners, see, it's not like male owners, within this owners are 0.2 million. So point out of the 0.2 million owners, we can say this way, yeah. 0.2 million owners, the male population is, let's point, let's 1 lakhs, or let's 0.1 m. You just think 0.1 m, okay? 0.1 m. So in this case, if you send the brochure to each customer, 0.1 m, only 1 lakh customers, 100,000 customers, you are sending $1 lakh. You are spending it by sending the brochure. And if they, the 0.1 million male customers, when they come and buy from your customers, if you send, even though you found the potential customer, instead of blindly sending the owners, all the owners, out of this owners, male population is 0.1 m. And even if you send the brochure or the catalog to 0.1 million males, there is no assurance all the males can come and buy, because probably they would have purchased somewhere else, or some people, they might be on travel. Some people, they would have purchased recently from your shop. Again, they will not buy it. So let's say, out of 0.1 million, 100,000, let's 50,000 customers, male customers, they come and buy it. And let's say per product, if you sell one product for this 50,000, you get 100 rupees profit. So what is your net income? 50,000 into 100, right? So how much you invested? 100,000, but you are getting something like this, okay? So the return is more. But you are spending less, but you are getting, your return is more by doing this kind of analysis. See how analytics helpful. So this is how you can, this is how, when you perform the analytics, you can cut down the cost and return, you can maximize your revenue. The next one is, I just simply, and again, within this gender, right, we will take a look at how many of them are married. So instead of gender, what I do is I'm going to say married. So here the winner is married people. In general, those who own the house, married people, they are spending more. Obviously, married people, they have a new house. They'll have to stay away from their parents in general, right? So most of the cases nowadays, the married couple, they stay away from their parents, and their expenses are more. They have kids. And now when I said kids, the next thing is, we found a column by the name of children. Now let us take a look at this one, children. When you see this, right, in the children, we have 0, 1, 2, 3, 0. So some customers, they have no kids. Some customers, they have only 1 kid, 2 kid, 3 kid. And those who own the house, still they are the winner. They are the ones spending more. There is no doubt here. But if you see here, the blue colored one, 0, those do not have kids. Their average spend is more compared to others. Obviously, when you have more kids, your spend will be less. Correct? That is what the phenomenon is. So in that case, still I can narrow down and target only these customers. See, your manager, your senior manager gave you the budget. See, boss, I can give you only $2,000. This is the budget. I don't know what you are going to do, but you need to get me more revenue or return. So see, as a smart manager, when you keep narrow down your analysis, right? So now you're able to understand, instead of sending 100,000 customer, because your budget is very less. So what you are doing smartly, are sending it to only this kind of people. Yes, we cannot use more than 3. Yes. So, right. So in that case, what will happen is, right. So you can narrow down, you can send the potential customers. Given my budget, so 2,000. So I can see that those customers do not own children. In the case of owners, right? Only 2,000 customers are there. If I target these 2 customers by sending $2,000, 2,000 per customer, if they come and buy it, let's say if I get 100 rupees per customer, 2,000 into 100, how much? So I'm able to maximize my revenue by targeting the right people. It's very simple. See, we have Lamborghini car. Lamborghini is very expensive car. You think every customer can afford to buy Lamborghini? You cannot, right? So you need to find out in the given population or in the given your customer base, which customers are having higher income, right? So those customers can obviously afford to buy a Lamborghini, and especially those do not have kids, they are more likely to buy this car because the salary is high, and they don't have to spend too much on children's education, and and already they own a house. The chances are high that they can come and buy Lamborghini. So if you target only, if you send the brochures only to those customers, the chances are that they can come and buy from your shop. So this is what box plot. Apart from this, we have something called strip plot. So I just select this one, and see the hue. The hue option is very much helpful, right? It is splitting these values, right? Your categorical variable own home itself, it splits this one. So here those customers own the house, and children wise, right? 0, no children, 1 children, 2 children, 3 children. So when you see this one, you can get another insight. Those have more kids, their spend is less, because in your shop they cannot come and buy, like those people do not have kids, because children education, they have to spend tuition expenses and bus travel expenses, many things are there, right? Next one is strip lot, own home and amount spent, and children, we will use the same thing, strip lot. So this one gives you more insight. Scatter plot, even though we use scatter plot, right? It gives us the relationship between 2 quantitative variable, but here, and we are using the quantitative, the categorical variable, this one. Within that itself, it gives you the, how scattered the values are. With this, we can make out the blue colored one. Those do not have kids, right? So their spend amount 1,000. You see more blue dots are there, and but the green, those have 2 kids also, they spend less than 1,000, and only few. But majority of the blue dots tells us, right, the spend pattern is, if you see the spend pattern 3,000 above, majority of the people, those do not have kids, they are spending more than 3,000. And this gives you more it gives you, a bit clear idea about, how scattered, right? The scattered plot, it's kind of a scattered values. And here also you can see that those, even in the case of those do not own the house, you can see a lot of blue here, right? They spend 1,000 above. And those have one kid also, they are spending. And green, oddly, rarely one guy spent, $3,000, especially those family have two kids. But the majority of the, if you see $1,000 and above, this color, orange color and blue only we can see it here, majority. So it gives you how scattered, the scattered view of the data, right? So with this, you can gain additional insight. So, okay, so it is already 6 o'clock. What we will do is we will circle back next week and we'll share this. So these two will share it to you all. Today's topic, okay, this part one and this one and the three files, right? I'll check it and I'll send these three files. You can download it. And these data files are already available in my GitHub. And if you do not know my GitHub already, I have told you. So you go to Power BI and download all the files, and you can go to Python scripts, Python somewhere here, Fantasy 200K. And yeah, best thing if you go to Fantasy 200K and see, if you remove this one, so when you are free, do some, Google, YouTube, all the things out of curiosity. Okay, you go and explore it. So what is GitHub, right? If you want to get into IT industry, if you want to earn more, you have to spend a lot of time. Look here, just go here. This is my ID, Fantasy 200K. And if you see here Python scripts, if you see here Python scripts are there, right? So that's all. So, and Python. And if you forget my GitHub, you watch my video, because at the end of the video, I explained everything repeatedly, right? And show more activity. When you click on this, you will find many things. Recently committed files, the PSQL, SQL related thing, Power BI, PBX, TSQL, everything is available here. You just go and watch it. And importantly, why to wait? You can, whenever time permits, you can go to my training in Chennai Info. Those opted for data science training, full stack, you have access to everything, right? So what you do is just go here, and importantly, Power BI also, you can see it. In the Power BI, you can find the SQL queries also. And you just go here and then see if the SQL topic is available here. All the videos are available here. If you click on anything, you will find, you can explore side by side the Power BI also. If you are not working anywhere, and would suggest you strongly to go here and explore everything. And SQL, let me do one thing. SQL, my SQL, okay, SQL assignment is there. Okay, SQL is yet to be loaded. I will ask my people to upload that video, Microsoft SQL. Okay, you watch that video also, start practice it side by side. So this is my link, and this is the one. I'll just share you one more time. And guys, please remember, in real-time scenario, once you get to inducted into the customer project, don't ask them the same thing again and again. Where is the where I can go and see intranet link? They will give you intranet link, and they will give you username. You need to save it somewhere. And this is the thing. You can go to directly here, and you can download everything. You can find TensorFlow and other computer vision related thing also here. And we'll let you know whether AWS or Azure. Okay, and based on which we'll take a call. So Azure Machine Learning Studio is also available, but the Amazon SDK is more popular. We will see, right? NLP, all the NLP related, auto NLP, and Amazon SageMaker related, Jupyter files also uploaded there. Azure is also there already. but not much you can find it here. These are things. Okay, you can simply go and computer vision. I uploaded it is not there. You can click on each and every look here. If you click on TSQL, you can see all the lab related, the Microsoft SQL related lab exercise demos, everything is available here. You can download it and simply go and simply downloads it. That's all. And DevOps, right? So DevOps at the end of this session will be covering it, the full stack data science, because you should be knowing how to deploy the model on cloud. That also, so look here, pre-trained models like VGG16, ResNet, MobileNet, all these things related content also you can find it here. See, and digit written thing, right? Yeah, so we need to, so in this one, I have used all these pre-trained models. Anyhow, it's too early to discuss or explore these things. At this moment, go to Python, Jupyter, or look here, Pandas, join, and whatever I trained you today, right? You can find it here itself. Even reshaping the data, you can start practice it. Next weekend, Saturday, I'm going to wrap up Python. It doesn't mean I'm not going to talk about Python forever, because after I finish the inferential statistics, during the course of inferential statistics, I'll be using Python to do the testing, how to do the hypothesis testing and all. How do we do it? Which packages are helpful in Python to do the hypothesis test? One sample t-test, two independent sample t-test. All those things I will demonstrate you in Python only. But the before we get into the machine learning, I'll cover whatever the basics or intermediate level of Python I'm going to cover it. At the time of machine learning, I will demonstrate you how to use Python related, machine learning related packages and TensorFlow related packages to develop your models and deploy it. And also we'll take a look at either AWS or Azure, how we can use SageMaker to create the model, train the model, all those things also, because nowadays everything is on cloud. Okay, so that's the reason why I'm planning to do that. Azure, one of my students already is working on this one. 2 years back he completed, and probably I will also ask him to share his experiences with respect to machine learning model later point in time. All right, so that's it from my side. Any questions from your side? Certification, yes, probably I'm still I'm in touch with some more guys. Most likely this Wednesday I will get to know. I will get back to you. I'll try to patch you with those guys already did the certification, so that they might be of helpful to you. Give me some time. Okay, I will check with them if they have already. I'll find out. See, there are some guys, my students, they finished the Power BI 100 DP 100 or so, not DS 100 or something like that. And Azure also I'll check with my people. Okay, those of them already completed, I will patch you with them, so that if you are planning for certification exam, they can be of they can be of helpful to you. But certification is not mandatory, but make sure that you are very good in algorithm. If you are very good in algorithm, if you are good with the cloud and deploying the models on cloud, that is more than sufficient. Believe me or not, my students, they are getting 0 year experience. I just stop the recording.